Okay, we're going to talk about the learning target. Learning target for today, I can identify parts of an expression and simplify expressions by combining like terms and using distributive property. You guys did a really great job yesterday with our intro activity, but we're going to go through to make sure that you do have a handheld version of the notes. Remember, the better that you take the notes, the better that you do on your quiz. You get to use your notes for your quiz, so you want to make sure you're taking accurate notes. Starting off, we're going to be splitting these up into the parts. We talked about terms, coefficients, variables, constants, all that wonderfulness. Yesterday we said terms basically were separated by addition and subtraction signs. So it could be just a variable. It could be a variable that is combined with a value, which indicates products or quotients. It could be just a single number by itself, but those were all considered terms. Essentially what we do is we look at the expression, and when we see an operation like subtraction or addition, we're basically putting up a wall in front of that sign. And it splits up what is one term, what is the next term. So in this situation, the 6x happens to be my first term. And then the positive 2 happens to be my second term. So those addition and subtraction signs are going to go ahead and divide it up. And you might have more than just one subtraction or addition sign. Now remember, the sign belongs to the number that it's in front of. So when it says plus 2, if we're looking at it independently, that means it's a positive 2. If it said minus 2, independently, that would be a negative 2. So you want to make sure that you don't drop the signs, especially those minus signs, because those minus signs mean negatives. Okay, then we've got our coefficients. Now our coefficient is going to be attached at the hip with your variable. It's being multiplied to the variable, or indicating how much of a variable you actually have. So in this case, the only coefficient that we have represented here is the 6. Now, a lot of you yesterday were making a mistake by, instead of putting just 6, you were putting 6x. But again, 6x is not a coefficient. 6x is a term. 6x is an entire term. 6 is the coefficient. That is the multiplier to our variable, which is our next thing. The variable, I'm going to highlight that in blue, is a numbered value, an unknown numbered value, so we essentially just call it a letter. And it could be any letter, but typically we see a lot of X's and Y's. We'll see A's, B's, W's. We don't tend to see O as a variable. We don't tend to see T as a variable, because those tend to get mixed up with operators or numbers. Okay, so O we don't see often because people might mistake it as a 0. We don't see T very often because it might get mistaken as a plus sign, and we don't have any other way of writing plus. Whereas multiplication, we have tons of ways of writing multiplication. So you're not going to see the X value, that little X multiplication symbol anymore. For now on, you guys are going to see them side by side or with parentheses. That's going to indicate your multiplication. All right? So here, X is going to be our variable. And then our constant. With our constant, the constant is what you are adding or subtracting that is just a number, no variable attached to it. It's independent to itself. Notice I'm going to include the plus sign with it so that I know that this is a positive 2 that I'm talking about for my constant. It is just a single number that's being added or subtracted in the expression. You must include the addition or subtraction sign as part of its integer value. Okay? Another thing that you want to make sure you're aware of is that there are differences between having a variable without any kind of exponent written and a variable with an exponent written. We're going to talk more about that on the next page in a little bit. But what I want you guys to do right now, very quickly, is go ahead and identify your terms, coefficients, variables, and constants for these two problems. You're going to do that by yourself. Let's go over it real quickly. So for 8x minus the 4, our terms are 8x and a negative 4. Don't forget to include that negative sign. If you forgot the negative sign, then that would be marked wrong. The coefficient is 8. The variable is x. The constant is negative 4. Okay, for problem 2, our terms, we have several terms here. We've got 3. We've got a negative 2x. a positive 9, a positive 7y, and a negative 13. Our coefficients are negative 2 and 7 because they're the only numbers that are attached to our variables, which our variables were x and y. And then our constants are the only numbers that are independent to themselves. So the 3, the positive 9, and then the negative 13. Those are going to be our constants. Any questions? Woohoo! All right, go ahead and flip it on over to the back. I have to go. Just remember, this will get posted into Google Classroom, so anything that you don't have written down, you can go ahead and copy it later. All right. So, like terms. When we're talking about like terms are going to be terms that have a common variable. So that's the important thing to understand. Like terms have a common variable and that they are raised to the same power, meaning an exponent. Okay, so on the previous slide I had said, hey, there's a difference between x and x to like the second power, or x to the third power. Okay, every single number has an exponent. 7's got an exponent. 4x has an exponent. All of these actually have an exponent. You just don't see the exponent. So if we don't see the exponent, what invisible number is there? A 1. We always know that invisible number of a 1 exists. So this means 7 to the first power. We just don't write 1 as an exponent. This means 4x to the first power. We're just not writing that exponent. But they all are happening to be to the same power. Now if I had a 4x and a negative half x squared, those would not be like terms because x and x squared are not the same power. Even though they're the same variable, they're not raised to the same exponent. So that would make them not like terms. You wouldn't be able to combine those together. Okay? So when we're looking here, the like terms that we happen to have, we've got a 7 is like termed with the negative 8. Why are they like terms? What are they both called? Yes, they are numbers. Very good. But what else are they called? Constants. The 7 and negative 8 are like terms because they are both constants. So that's one thing that we want to indicate. You don't just have to have a variable. If you are a constant, you are a like term with another constant, whether it's positive or negative. It doesn't matter. Okay? Then we've got 4x. Not right now. We've got 4x and negative half x. Those are like terms because, again, they both have the term or variable x. So 4x and negative half x. It does not matter that one of them's a fraction and one is a whole number. It doesn't matter that one's positive, one's negative. The fact that they both are in terms of x to the first power means that they're like terms. Okay, and then we've got negative 2y and a positive 0.6y. Again, they are the same type of variable. They're both terms of y to the first power. That makes them like terms. So negative 2y and 0.6y. So when we have like terms, we can combine those terms together by adding or subtracting the coefficients and then keeping the variable intact. So for example, for problem number 1, we've got 4x plus 3x. Because of the fact that they both are in terms of x, they both have the same variable of x, we can combine the coefficients, the 4 and the 3 together, and leave it in terms of x for the variable. So what's 4 plus 3? 7. So we would have 7x as our simplified answer. Okay, now taking a look at problem number 2, like I said yesterday, we always start with the variable terms that we have in common, and we always go alphabetically. The constant is always going to be at the end of our expression once we have it in simplest form. So we do have a 3x. It does have a like term. What's its like term? Not just 8x. Negative 8x. Don't forget that minus sign belongs to the 8x. That minus sign does belong to the 8x. So this would become 3x minus 8x. And then we have a plus 6 that's going to go down at the end of it. So what's 3x minus 8x? Negative 5x. Don't forget your variable. Negative 5x. And then plus 6. That would be our final answer. Okay, same thing for problem number 3. We've got a negative 2y plus 4x plus 2x plus 7y. We're going to start with our x variables first. So we have a positive 4x and we have a positive 2x that we're going to work with. So positive 4x plus 2x is going to give us what? 6x. Don't forget your variable. Do not forget your variable. Okay, then we've got a negative 2y and a positive 7y. So we have negative 2y plus 7y. When we do negative 2y plus 7y, we get a positive 5y. So there's our simplified expression, 6x plus 5y. Now, taking a look at problem number 4, again, we do have a like term. We've got n and a negative 9n. So what is n minus 9n? Nick? Negative 8n. Don't forget that the n does have an invisible value in front of it. That invisible value, in case you forgot, is a positive 1. So you're technically doing 1 minus 9. A lot of people make a mistake and go, oh, well, n minus 9, and it's just negative 9 then, because they're thinking they're getting rid of the n's. You're not. It's no different than when you were subtracting 3x minus 8x and you get negative 5x. You've got a 1n minus a 9n to get a negative 8n. Okay, then we've got a negative 4 plus 7. What's negative 4 plus 7? Positive 3. Okay, positive 3. The reason I'm indicating positive, I'm enunciating that positive, is because I know I have to put that plus sign. Because again, I'm writing this as an expression. If I don't put that plus sign, I just write 3, it's going to look awful. You've got to have that plus sign in between because it's a term, separating your terms out. Go ahead and do 5 and 6 on your own. Okay, for problem number 5, what did you guys get? What did you get? You got 12x minus 11. 12x minus 11 for problem number 5. Taking a look here. We got negative 3x plus 15x is 12x. Negative 9 minus 2 is a negative 11. So you get 12x minus 11. And what did you get for the last one? Number 6. Negative y plus 12. Good. So if you take a look, the negative 11x plus 11x comes out to 0x. But I don't have to write 0x. 0x means that x no longer exists. It's gone. Okay? Then when we have 7y minus 8y, we get negative 1y. Again, I don't have to write the 1. I can just write negative y. Okay? These are not the same. The reason x was able to be completely eliminated and left off is because there is no x value anymore. You still have to write a minus y here because there's one negative y that exists. And then plus 12 because there was nothing to be able to combine with it. We're going to skip the bottom part and move on to the last page. So go ahead and flip on over to the next page. All right. We're just going to do a couple of problems on this page real quickly. So distributive property. Remember, with distributive property, what this indicates is you're taking a value that is on the outside of your parentheses, your quantity, and you are multiplying it to each of the individual portions on the inside. Now, each of those terms on the inside are separate. So we have an A term. We also have a, in this case, a positive B term, but we don't know what value M is. But what this essentially means is that we're taking M and we're multiplying it with A, and then we're taking M and we're multiplying it with B, And then based off of whatever b is equal to, it could be a plus or a minus that value. Okay? If m and b are both positive or they're both negative, then it's going to wind up being plus that product. If one of those values is positive and the other value is negative, then it's going to wind up being minus that product. Okay? So if we're taking a look here at problem number 1, we're distributing the multiplication of this 2 to the 3x, and then we're going to multiply the 2 to this positive 7. You want to make sure you know whether it's a positive or negative that you're dealing with. So again, taking 2 times 3x, what's 2 times 3x going to give us? 6x. Then we're going to take 2 and we're going to multiply it by a positive 7. What's 2 times positive 7? 14. And it's positive 14, so what should I put? Am I just going to write 14 here? No, what do I need to put here to indicate that it was positive? A plus sign. You have to put the plus sign with it to indicate that 14 was a positive product. So there's your final answer, 6x plus 14. You can't combine anything because there are not like terms. Okay, it might seem silly that I keep indicating, okay, be careful about those signs, because when you get to a situation like here, a lot of kids mess up with distributing when there's a double negative. And here's what I mean by double negative. I know it's negative 4 is going to get multiplied to that first term, which is a 2x. Negative 4 times 2x is negative 8x. But then I've got to distribute negative 4 times a negative 3. That is a negative 3. Well, a negative times a negative is a what? Positive. But I can't tell you how many people go, oh, minus. They keep wanting to put minus instead because they saw a subtraction, so they want to put a minus. But it's not. It is a plus now. It is a plus 12. That double negative distribution is going to create a positive value here. And it's also important, we never put, here I'm going to scroll up to the top for just a moment so that you can see a little note. And I'll come right back down, don't worry. But up at the top, we do not do plus minus. We never do plus a negative number or minus a negative number. We do not do plus a negative number or minus a negative number. What we do wind up doing is just minus a number. Okay? Plus a negative number is just minus a number. Minus a negative number is plus a number. So if you see us saying, oh, it's plus negative 2, plus negative 2 just means minus 2. If you see me saying minus a negative 2, minus a negative 2 is just plus 2. Okay? You do not do those double signs. Double signs cannot be written there. You got to eliminate the double signs. If you see plus minus, it's just a minus. If you see minus minus, it's a plus. Everybody clear? All right. So taking a look here, all I want you guys to do, you're just going to do problem 3, 4, 6, and 7. Don't you dare do what I know what you're about to do. I know some of y'all, some of you are smiling too. I can see it. Don't you dare. 3, 4, 6, and problem number 7. I'm going to put that out there. Problem number 3, what did you guys get? Demi, what did you get for number 3?
I got negative 15x minus 18.
Good. Negative 15x minus 18y. Brooklyn, number 4?
12 minus 6y.
Where's your variables?
12x minus 6y.
12x minus 6y. Good. So we got negative 15x minus 18y for number 3, 12x minus 6y for number 4. What about for problem number 6? What do we get, Sawyer? Okay, sit down properly on the chair. Thank you. Paul, what'd you get? Number 6. Okay, take that off of your head. You guys talking so much and you make me think you're done. Ari, what'd you get? 24a minus 16b. Very good. And then for problem number 7, Jack? Not minus. There's the big mistake. Plus 55. So negative 5 times negative 11 is going to come out to a positive 55. Big mistakes are going to happen there all the time. You got to be very mindful of those signs. Be mindful of the signs. All right. What you have right now is loaded in Google Classroom is your assignment. You've got 2 activities, and they don't take long. They're not IXL. They are Google Slides. Now, since they are Google assignments, you must click Turn In when you are finished with both. You must mark them as done or click Turn In order to show that you're done. Let me go over them real quick.